Okay, guys, today we're going to talk about factoring polynomials. The first method that we're going to talk about is factoring using a greatest common factor. So when we are factoring any polynomial, this is always the first method that we want to try. Okay, whether we're looking at a binomial, a trinomial, a polynomial, you always want to look to make sure that there are no greatest common factors first. So we're going to start off by taking a look at a few polynomials, some binomials, some trinomials, and so on and so forth, and we're going to factor them using a greatest common factor. So what is factoring, you may ask? And factoring is the process of separating a polynomial back into a product. Now one question you may have is, what happens if the polynomial cannot be factored? So there's absolutely nothing you can do to factor the polynomial, and polynomials that cannot be factored, we call those prime. Okay? What I want to key in on here is there will be several ways to factor. The approach that we take depends on the polynomial, but you always want to make sure that you are identifying some sort of greatest common factor first. Okay, you always want to take that greatest common factor out first and then see what happens. So we're going to run through quite a few examples today, using the greatest common factor as a way to factor polynomials. Let me just erase some things first before we move forward. Okay. We'll come over here. We'll delete this. Do some more erasing. And we'll start with some examples. So here's example 1. We have 3x plus 12. So we're going to take a look at the 3x, and we look at the 12, and we look at we see here that we have a 3 for this term, and there's a 12 here for this term. So what I should be able to say is, well, the 3 and the 12, they have a greatest common factor, and their greatest common factor is 3. So if I take 3 out of this piece here, what I'm left with in parentheses is just x. And if I take the greatest common factor of 3 out of this 12, well, then I'm left with a positive 4. And what you're able to see here is, if I were to, okay, so this is actually your final answer. This is factored. We took the 3 out of both, and this is our final answer. But what I want you guys to see with factoring is, if we factored correctly, and we use 3x plus 4 as our solution, when we distribute this 3 out, what we actually get is 3x plus 12, and that is exactly what we once started with over here. Okay, so if factored correctly, you should be able to distribute out the product and arrive back at your solution. Okay, so again, this here is our solution right over here. And we'll take a look at another example. Okay, that was a very simple example. Example 2. Take a look at one like 7y minus 7. And I'm going to take a look here specifically at this 7 and this negative 7. And what I'm able to take a note of is that their greatest common factor happens to be 7. And if I take 7 out of 7y, what I'm left with is just y. And if I divide negative 7 by 7, what I'm left with is just negative 1. And that is our final solution. We'll go for another example. They're going to start getting a little bit more difficult. This is example 3. Let's take a look at 8m plus 36n. And the first thing I'm going to do is I'm going to take a look at this 8 and this 36. I'm going to ask myself, what is the greatest common factor that they both share? And in this case, if we ask ourselves 8 and 36, the greatest common factor would be 4. If I divide this piece by 4, what I'm left with is 2m. And if I divide this piece by 4, what I'm left with is 9n. Okay, then I'm going to take a look here just to see. There's an m here, there's an n here. There is no greatest common factor there. So that happens to be our final solution. Now I'm going to introduce an example where they share a greatest common factor both in the coefficient and in the variables. So let's just take a look at the example 4y squared minus 24y. And we take a look first at the coefficient of a 4 and a negative 24. And their greatest common factor happens to be a 4. Okay, and what I'm also left with here is now I'm going to take a look at this. We have a y squared and we have a y. Okay, and when they share the same variable, what we're going to do is we're going to take out the smallest one that they share, and here they happen to share at least a y. So if I divide this term by 4y, that cancels. Y squared divided by y. What I'm left with here is just y. And if I divide this term by 4y, we're going to get negative 6. So now what I'm able to take a look at and deduce here is, this is my final solution. But remember, in order to check ourselves and make sure that we have the right solution, we can take our solution and distribute it out to check. So let's just say we had 4y, y minus 6, and we distributed it. 4y times y gives me 4y squared, and 4y times negative 6 gives me negative 24y. That happens to be the same as the problem that we started with. Going to use a little bit more of a challenging type example. This is example 5. Let's go with 2x squared y minus 2xy squared plus 4xy. So the first thing I'm looking at is here we have this 2, this negative 2, and this positive 4. Their greatest common factor happens to be a 2. Then I'm going to come back in and I'm going to take a look at, we have an x squared, an x, and an x. So the smallest one that they all share is an x, so I can pull an x out. And we have a y here, a y squared, and a y, so they all share at least one y. Okay, and now I'm going to take this 2xy, and I'm going to divide everything by 2xy, 2xy, 2 divided by 2 is 1, x squared over x just leaves me with 1x here, and y, that simplifies out. We're going to come over here and we're going to divide this by 2xy. Negative 2 divided by 2 is going to leave me with at least a negative 1. X's are simplified out, and we're left with a y here. And we divide this by 2xy. 4 divided by 2 is positive 2. X divided by x simplifies out, simplifies out. And that is our final solution. You can check by redistributing. and you'll be able to tell that you end up with the original problem. Okay. And here goes one more example where a special case happens. Let's just say we're taking a look at the problem. This is example 6. Let's say we're given the problem 5x minus 13y. We take a look at this 5 here. We take a look at this 13 here. We notice that there is no greatest common factor there. We take a look at this x here, and we take a look at this y here. They don't share any x's or y's. So this is an example of a problem where we cannot factor it. And when we cannot factor a problem, what we're going to do is we're going to call this prime. I hope this little mini lesson helped you guys out. And if you guys have any questions with the homework, please let me know.